The AI supply chain includes the components, services, data, and processes that make an AI system work. This may include models, datasets, embeddings, vector databases, packages, containers, APIs, plugins, prompt tools, cloud services, and deployment pipelines. AI applications are rarely built from one isolated model. They are assembled from many moving parts that may come from internal teams, open source projects, commercial providers, and third-party services. If teams do not understand those parts, they cannot effectively manage risk. Visibility is the foundation for responsible AI engineering. Supply chain weaknesses can affect confidentiality, integrity, availability, safety, and trust. AI systems inherit traditional software risks and add AI-specific dependencies. A vulnerable package may expose systems. A poorly controlled model artifact may behave unpredictably. A low-quality dataset may create unreliable outputs. A third-party API outage may disrupt service. A plugin with excessive permissions may create unnecessary exposure, especially when model output can trigger actions or access sensitive resources. AI supply chain risk matters because weaknesses in upstream components can affect downstream decisions, products, customers, and users. Model provenance means understanding where a model came from, who created it, how it was trained or fine-tuned, and whether it is appropriate for the intended use. Teams should be cautious when downloading or integrating models from unknown or poorly documented sources. Model artifacts can raise licensing, security, performance, privacy, and reliability concerns. Model selection should involve more than checking whether a demo looks impressive. Teams need to understand limitations, intended use, maintenance, update practices, and evaluation results. Provenance helps teams decide whether a model belongs in a product, requires additional review, or should be limited to experimentation. AI systems often rely on datasets, documents, embeddings, and retrieval systems. If these sources are incomplete, biased, outdated, manipulated, or untrusted, model outputs may become unreliable or unsafe. Retrieval-augmented generation can improve usefulness, but it also introduces risk when untrusted content is treated as authoritative context. Teams should understand which data sources feed the system, who can modify them, how changes are reviewed, and how quality issues are detected. Strong data governance includes clear ownership, source validation, review workflows, update history, and monitoring for unexpected changes in output quality. AI applications still depend on ordinary software components. Packages, containers, libraries, CI/CD pipelines, cloud services, and infrastructure configurations all introduce risk. A secure AI system still needs software composition awareness, vulnerability management, patching, secrets management, build integrity, access control, and deployment discipline. AI does not remove traditional application security requirements. It adds new layers on top of them, including model artifacts, data pipelines, evaluation assets, prompt templates, and inference services. Teams should manage AI applications like software systems with additional AI-specific inventory, review, and governance needs. AI applications may connect to tools, plugins, APIs, databases, email systems, ticketing systems, cloud services, or code repositories. These integrations can make AI systems useful, but they also increase risk. If a model is manipulated or confused, excessive tool permissions can turn a bad output into a real action. Integrations should use least privilege, approval workflows for sensitive actions, clear logging, and careful access boundaries. Teams should define which tools the system can use, what data it can access, which actions require human approval, and how tool activity is monitored. Teams cannot manage what they do not know exists. AI supply chain risk management begins with inventory. Inventory should identify which models, datasets, packages, tools, prompts, APIs, services, and infrastructure components are used, who owns them, and how they are updated. Governance helps define review processes, ownership, approvals, acceptable use, exception handling, and documentation expectations. Monitoring helps teams detect unusual behavior, performance changes, dependency issues, unexpected access activity, and operational failures. Visibility makes improvement possible. Supply chain risk cannot be eliminated, but it can be reduced through layered controls and continuous improvement. Practical steps include maintaining inventories, reviewing model provenance, validating data sources, managing dependencies, securing build pipelines, limiting tool permissions, and reviewing third-party services. Teams should also monitor behavior, document ownership, define review workflows, and update systems as risks and dependencies change. The goal is not to freeze innovation. The goal is to build systems with enough visibility, discipline, and governance to manage risk responsibly. Supply chain risk extends traditional software supply chain risk into models, datasets, embeddings, retrieval systems, tools, plugins, prompts, APIs, cloud services, dependencies, and build pipelines. Teams should understand where components come from, who maintains them, how they are updated, what permissions they have, and how behavior is monitored. Effective risk reduction depends on inventory, provenance, data quality, least privilege, dependency management, governance, monitoring, and continuous improvement. Useful outputs are only one part of safety and security. Responsible AI engineering requires visibility across the whole system.